All right, taking a look at chapter 3, we are going to be learning about how best to present our GIS data. Specifically, we're going to be looking at the basic principles of map design, including the purpose of map design. And working within ArcGIS Pro, we're going to take a look at how to create text and labels on maps, as well as creating effective and aesthetically appealing layouts in order to print maps most effectively. So let's take a look at these concepts. Starting with the map design process, map design is an interactive 5-step process, which includes selecting, arranging, symbolizing, reviewing, and editing your data. And this is not a linear process, so each step refers back to the objective for the map. So generally, we begin by developing a vision of the map's objective, and this vision will inform each step that goes on beyond that. So by selecting the data, arranging our map page, symbolizing the information, and reviewing the map, editing and improving it will help us to ensure that we are going to support the objective of our data in every possible way. So using this diagram, you can see how even though we have to start by selecting the data that we want to use in order to portray our objective, as we move through and arrange our data and symbolize our data, we're constantly going back to seeing if our choices support the overall objective of the map. So it is by no means a linear process. You're constantly going back potentially, once you're reviewing the data, you realize you're missing some more data or realize you need to symbolize the data differently because something is going to have an issue as far as how it's been symbolized on the map, and it may be a little bit confusing. So ultimately, by the time you've completed a map and have an effective map design, you're going to be going back and forth through these processes a few times before you're done. Ultimately, though, the most important part of any map design process is identifying the objective. Developing a clearly defined objective for a map is critical, but sometimes neglected. It determines the form and content of the map and provides the context in which to review a map and ask whether it works. 4 issues should be considered when designing a map or determining the map objective. And that is going to include what is its purpose, who is the audience, what is the medium, and under what conditions will this map be viewed. Let's start with the map purpose. Maps serve different functions, and the function strongly influences all steps of the design. So the first question is, what is the purpose? And while a complete list of every map purpose is basically impossible to list, there are a few common ones that should be included. Locating points of interest, aka location. We need to navigate, navigating from one place to another, compiling complex data, convincing the reader of a fact or hypothesis, in essence, what we are trying to display on the map, comparing data from different times or locations, as well as analyzing data to learn new information. And whether you realize it or not, you are already familiar with several of these. So locating points of interest, this is very common on Google Maps. In essence, all Google Maps really attempts to do is get people from point A to point B. And in order to do that, it is critical that there are points of interest. So whether you're driving around and you're seeing a restaurant or a grocery store or a place of business that you had been to previously, they store your data. Locating points of interest and having points of interest clearly defined on a map is crucial to good map design. Similarly, navigating from one place to another, like a road atlas, is going to be also crucial depending on the objective of the map. A navigation map will tell us again how to get from point A to point B. Obviously, a road atlas is generally going to be a printed map, whereas the medium of a Google map is going to be generally online. And while it can be argued that location and navigation can be relatively simple, needing to compile complex data will make a map more complex. And so this is really when we come into our own with the powers of the GIS. So specifically using a geologic map, for example, Some of these maps can be very detailed, full of complex information, which might include utility network maps and construction of landscaping plans, right? If you think of underground sewers, power lines, manholes, gas lines, all of this other civil engineering component, as well as, rock type and where it's going to be easier potentially to set a foundation or where it won't. All of this data can also be displayed on a map, clearly changing the objective as well as how we would want to try and display this type of information. So part of determining the purpose of a map is to identify our target audience. Our audience will greatly influence the choice and representation of the data that we not only decide to include on our map, but also how we symbolize, or what symbology we use to symbolize this data on our maps. So coming back to our audience, it's crucial for us to understand who's going to be viewing our map, what type of knowledge do they have, or what do we expect them to have, knowledge about the subject matter, maps in general, and are there any special requirements, including colorblindness and large print. So referring back to how we symbolize our maps, if we know that our audience or this map is going to go out to a larger group of people, perhaps it's a government map, and we want to make sure that we are creating a map that is inclusive, we might want to take into account people who are colorblind and avoid making a map with symbology that would make it difficult for certain groups of people to read or understand our maps. Understanding the type of map that we need to create so that it suits our audience goes hand in hand with understanding what medium our map is going to be represented in. Will it be a paper map? Is it going to be an electronic map? Or perhaps people are just going to be viewing it through the computer screen. Is it a web map? All of these different things are going to come into play. So depending on which medium is going to be required, that will influence the decisions that you're going to make when compiling your data and displaying our information. In general, we have two main map mediums. One is going to be a paper map, our traditional map, as an example provided earlier, that atlas, that road map, versus a web map, which again, using the example previously, might include Google Maps. So while paper maps remain static and are not going to be able to change, web maps are going to be able to be interactive, meaning we can zoom in, zoom out, set different viewing sizes depending on where we're zoomed in or out. And so the conditions of use for the different type of medium that we are going to be presenting our map data in will also be of importance to take into account as we are designing and considering the purpose of our map. So take a minute and familiarize yourself with some of these examples of the pros and cons that can be attributed to these different types of map mediums, whether it's a paper map, a web map, a poster with large font, or a web map that might be viewed in poor light or sunlight, so maybe our symbology has to be really bright and intense. Read through these and familiarize yourself with the pros and cons of each of these mediums and consider how the condition of use can impact the medium that is chosen. Once you have a clear purpose of the map and you know what type of medium your map is going to be, generally we are going to be making web maps, although sometimes you will be asked to print these maps out. So again, once the purpose of your map is clear, we have to decide what type of data is going to be displayed to effectively tell the story of our map. So, selecting our data layers, in general, a good map will always tell a story. Because a good map will tell a story, it's important to know who the quote-unquote key players are, what is the most important data that we are representing, what supporting data do we need in order to provide context for the map, and have we provided or is there some data that is being displayed on the map that is unnecessary and potentially cluttering up our map, making it more confusing for our audience to understand the purpose and data of our map. So a key component when it comes to selecting which data layers we are representing truly is the selection part. Because we have a wealth of information at our fingertips, it is often more tricky to remove what isn't needed. Simplicity is one of the guiding tenets of cartography. Every piece of data should work to support the map objective. So ultimately, we don't want to have a cluttered map. Is there other data that we might want to or need to omit depending on what we've created? Potentially considering privacy issues or sensitive information, we always need to be aware of unattended consequences that our map data may be displaying. You can see there are quite a few examples here listing potential consequences of the information that we may be displaying on a map. We want to be careful when publishing things like parcel owner names, or perhaps indicating where an endangered species may be, as that could be impacting poaching issues. Vandalism, or even at this point, blackmail or terrorism could come into question when we are looking at the location of certain pipelines, whether it's issues of oil or potentially even issues of water. Also, showing something like a fault line where it might intersect a specific parcel, this could, lower property values, which could negatively impact the community at large. So it's always crucial to consider what impacts your map and the data that your map is showing may have. In addition to determining which data is going to be and needs to be represented or shown on a map, and potentially which data needs to be omitted, we also need to consider the scale of our map. Remember that a large-scale map is in essence zoomed in. The features on our maps are large, and a small-scale map is zoomed really far out where the features on our map are small. So it's important when we are looking at how we are symbolizing our data, or depending on which layers we are using, some data layers are going to be best used for either a small-scale map or a large-scale map. And so when we are shuffling between the different data that we have access to, often we are going to have to simplify our data sets for better performance, not only loading and downloading something on a web map, but also visual performance on a map. So the process of simplifying these data sets is often referred to as cartographic generalization. To simplify our data and make it more user-friendly, cartographers will often use the following techniques: exaggeration, displace, typify, reclassify, collapse, aggregate, simplify, or refine the data. Let's take a look at them individually. Exaggerating data will often give a feature more importance or more prominence on a map. For example, increasing the width or the size of a body of water will make it more prevalent on a map. Displacing features slightly will ensure that they do not run over each other. So for the example provided here, if we move a road to avoid the appearance of an intersection with another road, this will make it clear that these are two separate roads and not a single intersection. Typifying features means that we are using a representation rather than the actual location of that feature. So for example, we can replace the specific point markers for actual homes with a smaller number of fake points representing scattered housing. These first three cartographic generalizations, exaggerate, displace, and typify, falls under a type of generalization known as falsifying data. While this should be used sparingly, and a note should be made on the map indicating that these techniques have been used, sometimes it can be a very effective tool when it comes to representing data, again, depending on the scale at which our data is being represented or shown on a map. The rest of the generalization functions allow us to more effectively present information from a large-scale map at a smaller scale. Whether you are refining, simplifying, aggregating, collapsing, or classifying this data, ultimately we are simplifying or generalizing our data to go from a more complex visualization to a generalized visualization, making displaying this data on our maps easier. In addition to generalizing our information, we may employ the use of specific map grids to further clarify where in the world our data is being presented. Whether we are using a reticule grid, a measurement grid, or an index grid, they can be incredibly beneficial to let our audience know where in the world the data that we are representing in our map is located. A good map layout will generally contain many of the following map elements. While we've touched on quite a few of these, including the title, the scale bar, the legend, our north arrow, and citations, we have not talked about so much the location map, neat lines, or additional graphics or photos. So a location map is going to be an additional map that will help the audience or the reader of the map determine what extent our map actually covers. A neat line is going to enclose the entire map or groups of elements within the map to help the map with its overall aesthetic appeal. Graphics or photos may also be inserted into our map to further elevate or better detail the specific information that is being portrayed or represented in our maps. I want you now to take a minute, look at this map, analyze the map, and figure out what stood out to you most, what was the map about, what did you notice first, and pay attention to how your eyes move around the map. Do that now. Consider which elements are the main characters or the supporting characters of the story of this map. Pause the video if you need to. In a map, the direction of the story and the relative importance of the elements is achieved by establishing a visual hierarchy. And establishing a visual hierarchy refers to the order in which the reader perceives the different objects in a design. A good map establishes a clear pathway through the map by using carefully arranged elements and appropriate symbols. A key to arranging map elements effectively is to balance the elements of the map. The visual center of a page is about 5% higher than the geometric center. Maps centered on the geometric center may feel a little bit heavy towards the bottom. So elevating them just slightly above the actual center point of your map is going to make it feel more balanced. The rule of thirds is a graphic arts principle used to enliven a design. And while it's primarily used as a guide for composing photographs, it can also be helpful when creating a map. Imagine the page being cut into horizontal and vertical thirds. Right? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. The important elements should be placed on the intersections of these thirds, as it will have a greater visual impact than just being placed in the center of a map. The alignment of your map elements is equally as important. Arranging your map elements into columns or rows, rather than letting them wander all over the page, will ensure that your map will have a cohesive design. You will learn that you're going to be able to connect the edges of boxes and map frames by snapping them to the guidelines that are available in Arc Pro. And one of the most underrated skills when it comes to map design is the effective use of negative space. The effective use of negative space on a map will allow you to better balance the elements represented on the map, avoid overcrowding or unnecessarily open areas. The use of negative space is a design tool that will separate or combine elements in a more subtle way than using neat lines. Maps often look better when a map designer can effectively use negative space rather than putting every element within a neat line. This cartographic component, right, this is the design component, often requires a little bit of creativity in achieving balance, especially when dealing with irregular shapes like the state of California. So take a minute and look at maps A, B, and C and compare the use of negative space and the arrangement of the elements on the map and see which one you find most visually appealing. If you picked map C, I agree with you. There's a really good use of negative space. It aligns with the state of California, as well as the map feels more balanced, and you can see the lack of neat line makes the map feel more balanced. While determining which map elements need to be presented on your map, as well as establishing visual hierarchy and creating a balance of all of these elements on your map are incredibly important, there are plenty of other things to consider when creating an effective map. Most notably, how we symbolize our data through the use of color, contrasts, size, and shape of the elements displayed on our map. As the rest of this chapter is generally concerned with how to symbolize data from a color and size perspective, we are going to quickly breeze over this, as this is closer related to general design components rather than specifically relating to maps. The ease of determining the difference between your foreground and background spaces is easily done through the use of color. And not only color, but also the use of contrast. Dark colors and high contrast bring symbol to the foreground, meaning more obvious, and thus focuses attention towards them. If you have a less important symbol, you can make those colors less contrasting, and they will fade away into the background. You can vary symbols to highlight the importance and de-emphasize the less important symbols through size, color, style, or contrast. Interestingly, humans do not simply perceive objects on a page because the brain is constantly trying to organize these objects into specific patterns. So take a minute and analyze these 5 boxes and pay attention to how your brain tries to group these markers and which colors, sizes, or shapes of these symbols become easier or less easy to identify. When evaluating these symbols and layers, take note of how your mind tries to group or separate these objects and use these effects to help support the visual hierarchy that you are going to attempt to create on your maps in the future. So clearly, color is more effective than shape to highlight certain categories, and in general, changes in size are usually going to signify a change in quantity. Larger shapes meaning larger areas, smaller shapes meaning smaller areas. And so an effective use of different colors, sizes, and shapes is going to be the best way to organize your map data. As mentioned before, in order to differentiate between the foreground and the background, using different contrasts and colors will help to emphasize this. Looking at the visual difference between maps A and B, you can see that the use of lighter, lower contrast symbols, like the light blue ocean in map B, signifies that the ocean is less important than the features that pop on map B, aka the continents, and makes it easier for the reader to differentiate the important information on map B, while map A, where all of the colors have a high contrast, makes it more difficult for the reader to figure out what exactly is going on. So when comparing maps A and B, we can see that map B has established a much better visual hierarchy regarding the important information, or just generally the information that they are attempting to display on their map. And a great way to becoming more familiar with how best to establish visual hierarchies on a map is to study base maps and learn how other cartographers symbolize a map and how that map is designed to support the objective of the cartographer. You can do this again in ArcPro by clicking through the different options that they provide for their base maps. And you'll see that there are different themes established as well as different visual hierarchies depending on which information is more pertinent for the map that you are curating. And as we dip our toes deeper into the cartographic element, right, that is the visual component, the artistic component of map making, being detail-oriented is going to remain incredibly important. For example, using real words and not cryptic file names or field names is going to be most effective when displaying appropriate numbers and figures on a map. Moving your information away from neat lines is also going to help your map feel less crowded and establish a more aesthetically appealing map. Compare the following legends and determine which of the following would best be used on a map. Clearly, legend B is easier to read. Finally, go ahead and review this map. Take into account the orientation of the page, the amount of data that is being shown, what data is most important, what colors are being represented. Consider all of the different map elements that we've talked about, as well as the balance of the map, and determine what works and what doesn't work for this map. How might we be able to improve the visual representation of this map to make it not only more aesthetically appealing, but easier for the audience to read and understand the map regarding the data that is being displayed. I highly recommend taking a detailed look at this map, jotting something down before going on to the next map to see how we might be able to improve this map. Here you can see a list of improvements that would help to make this map much better. There's a better balance of negative space, data has been better arranged, unnecessary data has been removed, and other distracting visual features through the use of color and contrast have also been removed to make it clear what this map is attempting to show. And ultimately, it is important to note that while this map is much better than the previous map, there is no such thing as a perfect map. There is a definite and definitive difference between a good map and a bad map, but ultimately, how data is displayed and what data is displayed is up to the cartographer. And only through trial and error are you going to become more skilled at effectively visualizing and representing your data and making effective maps. The rest of the chapter helps walk you through how to create a map layout using ArcPro, but this lecture will not go into that. Make sure that you read through the rest of the chapter. The information presented there is going to be important, as you will have to answer questions for this week's quiz. If there are any questions or concerns, please don't hesitate in contacting me. I am always happy to assist. Thanks.